All right, we are going to look at 3 examples of how to solve absolute value equations using this flowchart. So to begin with, we have our first example, and the first question is, look at your equation, is the absolute value isolated, which means, is the absolute value portion completely by itself? And for this one, we're gonna say, nope, it is not isolated. So going to this next step, it says rewrite the equation so that the absolute value is completely isolated, so it is completely by itself. So we're going to go ahead and copy that initial equation down. And then from here, we're going to start isolating. So our game plan is going to be get rid of the constant and then get rid of the coefficient. So the first thing we should do is subtract 5 from both sides, which will bring it down to 15. And then we should divide both sides by 3, which will just leave the absolute value equaling 5. So this is where we are now. Going to the next step, it says, is the absolute value equal to a negative number? It's equal to positive 5, so nope. So we're going to keep going down the no path. Next step, split your isolated absolute value equation into 2 regular equations by taking the inside of the absolute value and setting it equal to the positive and the negative version of the other side of the equation. So let's go ahead and rewrite the last thing that we had, the absolute value of 2x minus 5 equaling 5. And we're going to break it into those 2 separate cases. So we're going to take the inside of the absolute value and set it equal to the positive version, so 5. And then we're also going to take the inside of the absolute value and set it equal to the negative version of the other side, so negative 5. So those are 2 regular non-absolute value equations at this point. And like we said, the inside is set equal to 5 and negative 5. So now we're going to solve both of these equations. So I'm going to copy them back down. We have 2x minus 5 equaling positive 5. And then we have 2x minus 5 equaling negative 5. And we're going to go through our steps. So we should add 5 on both sides, right? And if you want, you can be really good and show all those steps. Then divide by 2. So we get 5. And then doing very similar steps on the other side. We get x equals 0. Now, one thing about absolute value equations is they are very prone to having what are called extraneous solutions. So our final step, step number 5, says check to see if any of your solutions are extraneous, and then if you have multiple solutions, write it in a solution set. So we're going to go back to our original equation, which is 3 times the absolute value of 2x minus 5 plus 5 equaling 20. And we're going to check for x equals 5 if that works, and for x equals 0 if that works. So we're going to have 3 times the absolute value of 2 of our x, which in this case we're checking 5 minus 5 plus 5, and we're going to say, okay, does this really equal 20? And then we're going to do the same thing down here, but instead of x being 5, we're testing our other solution, which was 0. And we're just going to fact check, okay, does that really make 20? So if we start doing the math, 2 times 5 is 10. Take away 5 is 5. The absolute value of 5 remains 5. Multiplied by 3 is 15. Plus 5, that's 20. So our solution of 5 checks out because it makes our equation true. Let's do the same thing with 0. So 2 times 0 is 0. Subtract 5, we're at negative 5. When you absolute value negative 5, it becomes positive 5. Multiplied by 3 is 15, plus 5 is 20. And that works out the way it's supposed to as well. Now, of course, you could show more steps than this. I kind of walked through it and talked through it, doing it in my head, but you could show all of the little steps of evaluating that absolute value expression. But both of our equations were true after we substituted in 5 and 0 for x, which means we can say x equals 0 or 5 as solutions. So my preference is to use a solution set in order of least to greatest solution, but you could technically write 5 and then 0. It doesn't really matter. All right, so zooming out just so you can see all of this example at once. Here you go. This is example 1. All right, going on to our next example, example number 2. So we're going to start the exact same, which is look at the given equation. Is the absolute value, so in this case, the absolute value of x minus 2, is it isolated? So isolated means all by itself. No, it is not. So our first step that we're going to do is isolate that absolute value. So that just means solve for it so it's all by itself. So we are just going to copy down that initial equation and then solve. So that means minus 9 divided by 4. So if you subtract 9 from both sides, we're at negative 8. Dividing by 4 tells us the absolute value of x minus 2 equals negative 2. All right, so that is our isolated version of this equation. Following the arrow, we're going this way. So step 2, is the absolute value equal to a negative number? Yeah, it actually equals negative 2, so yes, indeed. All right, following the arrows, now we're going this way through the flow chart. It says an absolute value is always greater than or equal to 0, therefore, it can never equal a negative number. Right, so the absolute value's job is to always find the distance from 0. Distance is positive. So because of this, there is no world in which an absolute value could equal negative 2. Therefore, no solution. So the way that we write this, this symbol here is called the empty set, which means the set of no solutions. So you could either write the words no solution, or you could write this symbol, which again is called the empty set. Sometimes you'll hear it referred to as the null set. That's a bit more old-fashioned, but it still comes up. And it just means the answer of having no answer. It's not the same as saying 0, right? 0 is a number. This is the answer of nothingness. Nothing will make this work. So that's the end of this problem. Personally, I'm always kind of excited when I get these special case solutions because it saves you a little bit of effort. You have to be careful and watch out for them. If you were to continue solving this and go through all the steps, step 5 down here would save you in the end when you check for extraneous solutions, and you'd find that both of your answers were indeed extraneous, which means you would come back to having no solution. All right, for our final example, it's the closest we've gotten so far to having the absolute value being isolated, but there's still a 2 in front. So once again, no, it is not isolated. So we have to go down this path to begin with. So we are going to solve the equation down so that the absolute value is isolated. So that means dividing both sides by 2. All right, so at this point, the absolute value is isolated. And then following our flow chart, the arrow says go this way. Is the absolute value equal to a negative number? No, it technically could be, I suppose, because x has the potential of being negative, but we don't really know what that is. Even if this was negative 2x, we wouldn't really consider that equal a negative number because there's a variable there, and a variable could take on any value. So we're going to go down this no pathway and continue solving. So this says take what we have, so we're at absolute value of x plus 6 equaling 2x, and split it equal to 2 equations. Right, so it says equal to the positive and the negative version of the other side. So we're going to have x plus 6 equals positive 2x, and then separately we're going to have x plus 6 equals negative 2x. All right, so these are our two equations, and we are going to go down to step 4 and solve both of them. So just copying down what we need to solve, x plus 6 equals 2x, and then x plus 6 equals negative 2x. Our solving steps are going to look very similar on both of these. It's just one has a positive, one has a negative 2. So looking at what we have, plenty of ways that you could go about this. I'm going to choose to subtract x on both sides. So this gives me 6 equals 1x. I could write the 1, but not necessary. So I'm just going to say 6 equals x, which that's solved. Then on the other side, if we subtract x from both sides, this gives me 6 equals negative 3x. So I'll divide both sides by negative 3, which means negative 2 equals x. So neither of these are guaranteed solutions. As a reminder, our next step is going to have us check for extraneous solutions. They are very common when solving absolute value equations. So right now, I would say that these are candidates. They are potential solutions, but until we check, we don't know anything for certain. So the first one that I'm going to check is x is 6, and then the other number we're going to check is x is negative 2. And we're going to go back to that original equation of twice the absolute value of x plus 6. So 2 times the absolute value of x plus 6. And that is supposed to equal, if we look, 4 times our x value. So if we do 4 times our x happens to be 6 in this case. All right, so doing our math, this side is 24, and then the other side, we have 6 plus 6, that's 12, absolute valued, remains 12, multiplied by 2. 12 times 2 is 24. So this tells us that our solution of x equals 6 checks out and is a real solution. We're going to do the same thing for our other solution, or potential solution, I should say. So we're going to substitute in negative 2 for x. So everywhere there used to be an x, we're going to put negative 2 and see if this works out. Alrighty, so on the other side, that's negative 8. On the first side, this would be 4, right? Negative 2 plus 6 is 4. Absolute valued is still 4. Multiplied by 2 is 8. So this one would not check out because 8 does not equal negative 8, right? Having $8 is not the same thing as having $8 of debt. Therefore, we would say that this is extraneous. Well, specifically, right, I'm going to be careful where my arrow is going. The solution of x equals negative 2 is extraneous, which means it's really just an extra byproduct of the solving process that doesn't really check out in the end. So our one and only solution this time is x equals 6. Now, because there's only one solution, you don't really need a solution set. If you really wanted to, you could still put the set brackets around it. But when there's only one solution, we don't typically do that, but it wouldn't be wrong. So just comparing and contrasting that with our first example that had 2 real solutions. We used solution set for that one. Our second example actually didn't have any solutions at all, so we used the empty set. Right? You could think of that as like the solution set that has nothing whatsoever inside of it. And then our final example, it appeared like we had 2 solutions to begin with, but when we did the math to check it out in the end, one of them was extraneous, leaving us only with one final solution. So here's a quick overview of how you solve absolute value equations. You can use a blank flowchart whenever you get stuck to help you out.